Assalamu alaikum everyone. So let's continue our integration series with model number 13. Right? Model number 13, and this is integration applied to inverse function. Before starting this model, I would like to say that if you haven't subscribed to our channel, please do so. And if you want private tuitions from me personally, contact below in the number provided in the description, and we will get in touch shortly. All right, so let's start it. The inverse function we are talking about here is inverse of tan. All right, inverse of tan inverse x. All right, this is the function for which we learned differentiation as well, and this is the same function, inverse function, that we will learn to integrate as well. All right, sin inverse x and cos inverse x are not part of our course. All right, these two are not part of our course, and this is the only inverse function that is part of our course. So firstly, let's recall differentiation of this function which we studied. We studied that when we see y tan inverse x, the differentiation would be dy over dx 1 upon 1 plus x square. All right, since integration is the reverse process of differentiation, so the integration of this function would be this, right? Let's understand it through more clearly through examples. Let's say we have simply 1 upon 1 plus x square, right? So it would be tan inverse x plus c. This is very simple. But what if we have another constant instead of 1? Let's say we have another constant here. Let's say we have 1 upon a square plus x square. All right. So the standard formula for this would be 1 upon a. All right. We will not include the square here, only a. All right. 1 upon a tan inverse x upon a plus c. This is how you would integrate the given situation. All right. Let's say we have 1 upon 1 plus bx square. Notice this time we have 1 here, but a different constant attached with x, and the whole thing uh, power square. All right. So it would be different integrated as follows: 1 upon b tan inverse bx plus c. 1 upon b tan inverse bx plus c. All right. Now, till here, you don't have to remember anything. Now, I'm coming up with a standard formula that combines these two. All right. What if we have, let me show it through an example here. What if we have 1 upon a square plus bx square? All right. What if we have this? So the standard formula which you need to learn is the integration would be 1 upon AB tan inverse B upon A x plus C. This is something you should remember. Whenever you encounter an integration in this particular order, all right? 1 upon AB, where B is inside the bracket, tan inverse B upon A x plus C, all right? Once you learn this, this would be applied in every question of this manner, all right? This is what's happening here as well, all right? We encountered this and we need to integrate this, all right? So 1 upon AB, since A, B is are A and B are both 1, so it would be 1 in this case. 1 upon AB, tan inverse B upon A. Still we have 1, 1 upon 1 x, right? Plus C, 1 upon AB tan inverse B upon A x plus C. So we just simply write it as tan inverse x plus C, all right? So this is something you should remember. Now, of course, this doesn't make much of a sense right now. Let's jump into questions where this is being applied, and I'm sure it will make sense. All right. So let's say we have with us 1 upon x square plus 25. All right. Now this is A and this is B. All right. Rearrange it. 1 upon 25 plus x square. Now it should also be in this form, all right, expressed like this, 1 upon 5 square plus x square in the square form, all right. Now you can apply this formula which we learned, which is 1 upon AB tan inverse B upon A x, of course, plus C, right? Now just apply it and the answer would be 1 upon AB. We have 5 B tan inverse B upon A x upon, since B is 1, we will write nothing here, x upon A5 plus C, all right? So this is how you will integrate it using this standard formula. Let's do another example. Let's say we have with us, we need to integrate 1 upon 1 plus 9x square, all right? Let's rearrange it in a manner, let's write it in a manner on which the formula can be applied. So it would be 1 plus 3x the whole thing square, all right? Because that's what the formula is being applied to. Now, since we have A and since we have B with us, now we can apply this formula, which is 1 upon AB tan inverse B upon A x plus C. Or if you apply this, you will get 1 upon AB, 1 upon 3 tan inverse B upon A, which means 3 upon 1 x plus C, right? Now let's look at another example. Let's say we have with us 1 upon 16 plus 25x square. We'll first have to express it in a manner on which the formula can be applied. All right. So let's do that. So 16 can be rewritten as 4 square. All right. Plus 25 can be written as 5x the whole thing square. All right. Now we can apply the formula, which is, since we have A and since we have B with us, we can apply the formula 1 upon AB tan inverse B upon AX plus C. All right. So 1 upon AB, 4 into 5 tan inverse B upon A, 5 upon 4 X plus C. So 1 upon 20 tan inverse 5 upon 4 X plus C. So this would be the answer. I hope this concept is clear. All right. Now we are going to do a question which I think matches the difficulty level of that in the actual exam, in the actual CAI exam. So let's do that question, which will obviously compile the models which we studied so far. All right. So the question is x tan inverse of x. All right. We need to integrate x tan inverse of x. Now, please observe that two functions are being multiplied in such a manner that there exists no common relationship between the functions. So what we will do, we studied in the previous model, that if two functions are being multiplied in such a manner, we will apply liet. All right, we will apply liet. Now notice that the first term appearing in the liet order is an inverse function. All right, so the first term appearing is an inverse function, so this would be u dash, and the second term trigonometric function is here. It would be v. Sorry. Uh, the first term appearing is v, and the next term appearing is u dash. All right. The first term appearing in the liet order is what? Is v. All right. So tan inverse would be v, and the next term, which is the trigonometric function, will be u dash. All right. Sorry for the confusion here. The first term appearing in the liet order is v, and the next term appearing in the liet order is u dash. I hope this is clear. So let's write it like this. V is equal to tan inverse of x, and u dash is x. All right. So v dash would be 1 upon 1 plus x square, and u would be, the integral would be x square upon 2. Now we will apply the standard formula which we learned, that is vu minus integral of uv dash. So we have with us v. All right. V is tan inverse of x, and u is x square upon 2 minus integral of uv dash. U is x square upon 2, and v dash is 1 upon 1 plus x square. All right. And one side note here, that u dash will never be applied in this function. All right. We will only be dealing with v dash, and u, if you haven't observed it already. All right. So let's do this on a fresh page because we are running out of space here. All right. What is this? Where did this come from? I'm so sorry. Yeah, let's just write it again. Never mind. All right, so it was vu minus integral of uv dash. So it was x square upon 2 tan inverse of x minus integral of uv dash, which was x square upon 2 1 plus x square. All right. This is the same thing, just rearranged in a more friendly manner. So let's do it. All right. So we have x square upon 2 tan inverse of x. Let's move 2 outside, minus 1 upon 2 x square upon 1 plus x square. All right. So now notice that we cannot, this is not in this manner. If it were in this manner, we could have simply integrated it as follows, right? Tan inverse of x. The integral of this would be this, as we studied earlier. But unfortunately, this is not in that manner. So what we are going to do is that we are going to divide it. All right. We are going to divide x square by 1 plus x square. All right. 1 plus x square. Because notice that they both have the same powers. It is an improper function. All right. And as we studied in this chapter of, you know, earlier chapters, what we will do is we will simply divide it. 0 plus x square. All right. So as we divide it, we will get 0. All right. So we will get 1 whole minus 1 upon 1 plus x square. So, all right. Now we can put this in place of this. So let's do it. So it would be x square upon 2 tan inverse of x minus 1 upon 2 integrate 1 minus 1 upon 1 plus x square. All right. Now we can easily integrate this. So it would be x square upon 2 tan inverse of x minus 1 upon 2, and if we integrate this, we'll get x, and this would be easily 1 upon AB tan inverse of x plus c. We'll apply that formula here, but since we have no other constants attached to either x or here, we can simply integrate it like this. All right. So this will be minus minus plus 1 upon 2 tan inverse of x is going to be our answer. And don't forget to attach plus c here. All right. So this is how we integrate it. All right. So this is integration by parts for you. And now we are only left with two models, which are which you must have encountered in AS, but we will still recap them. All right. And if you're watching till here, I would totally recommend you to subscribe this channel, as we will be covering other topics of integration as well. Not integration, but as other topics of A-level math. All right. And if you want private tuitions from me, you can contact me in the number provided below. Thank you so much. Take care. Allah Hafiz.